All right, for today's lesson, we're going to learn about the Factor Theorem, and we'll talk about that here in a second. And we're going to do a lot more synthetic division, so what we've already learned is definitely going to, if you're doing well with that, it's going to pay off. And we're just kind of taking synthetic division and division in general and making it a little more meaningful instead of just doing it just to do it. So let's look at this thing. So I already wrote it down for you. We have the Factor Theorem. And I'll kind of read this and we'll talk about it a little bit. Here's the Factor Theorem right here. But I think once we do a problem, we can go back to it again and talk about it. So it's the Factor Theorem says that x minus r, or think of that, I wrote the problem down, our first problem down here at the same time. So as we read this, we can kind of look at this. So x minus r is kind of going to be like our factor right here, x plus 2. Because the question that we're going to answer is x plus 2 a factor of this thing? Is it a factor of it? And the Factor Theorem says x minus r, or it could be this thing. This is the generic version where they just put a number or a letter there. This would be that. Is a factor of p of x, which would be the whole thing here. This is our polynomial, p for polynomial, x just meaning it's got x's in it. If and only if p of r equals 0, basically meaning the remainder, if we use synthetic division, the remainder, if it is 0, then it is a factor. We're babbling a little bit, so let's just go do it and see where it goes from there. So when I look at this problem down here and they're asking me, is this thing a factor of this? Basically all it really means, all this Factor Theorem means, is if I divide this thing into this and there's no remainder, then it was a factor. Or in other words, if the remainder is 0, then this thing, whatever it is a factor. So the fast way to divide x plus 2, let's do it synthetic division. So we're going to go -2. Remember, if it's x plus 2, then it's -2 on the outside. And then we're going to make our little L. We have 1, 8, 17, and 10. And we just, here we go, synthetic division. Drop down the 1, multiply, add, multiply, add, multiply,
Mr. Acosta, please.
And add. I shut it off for a second for those announcements that were going on. And notice the remainder is 0, and therefore, yes. The answer is yes. Yes, x plus 2 is a factor because when I divided by x plus 2, which remember, when I put -2 here, I am dividing synthetically x plus 2 into this thing. And when I did that, I got 0 as my remainder. Therefore, yes, that's a factor. All right, one more time. Same exact thing. No harder, no easier, just the same, basically, just to see it one more time. They're asking if this thing right here is a factor of this. So we could do long division and write it all out and see if we have any remainder, or we can just, which we should do, is use synthetic division. So we're going to put a 3 on the outside, 1, 4, -15, -18, and get really good at this because you're going to do it a whole bunch. Drop down the 1, multiply, add, multiply, add, multiply, add. Once again, we have a 0 there for the remainder. Therefore, this divides evenly into this with no remainder. Let me say that again. I'm going to say it slow. This thing right here divided evenly into this because I have no remainder. If something divides evenly into something else, then it is a factor of it. So all you got to do now is say yes. So it's basically, when you do these problems, it's a yes or no and a little bit of work to kind of prove it, all focused on that spot right there, the remainder. All right, let's step it up a notch here. Here we go. This next problem is worded a little different. It says if x minus 4 is a factor, or in other words, they're basically saying that this is a factor of this. Find the remaining factors. So what's going on here is they're basically telling you one of the factors. We're going to do it, we're going to divide it, but they're saying it's going to be a factor. So watch, x minus 4, since they're claiming that to be a factor, we're going to do synthetic division with the number 4. And here we go. 1, 3, negative 36, 32. Now, I guarantee you, unless this problem was messed up in some way, this is going to be a 0 over here because this is a factor. So we'll start with that. So 1, 4, 7, 28. Negative 36 plus 28 is negative 8. And 4 times negative 8 is negative 32. And we get our 0. Okay. So x minus 4 is a factor of this, which doesn't really help us because the question was find the remaining factors. I mean, it's going to help us, but it didn't do anything yet. We haven't actually found any other answers yet. But here's what we have now. We now know that when we divided this into this, our leftover, our answer basically to that problem is right here with the remainder of 0. So let's go ahead and bring this back as a regular polynomial, x squared plus 7x minus 8. And now that's just a squared polynomial, so we can just factor that. We're gonna factor that now. We don't need any synthetic division anymore. Whenever you get it down to a squared equation, you're gonna use your regular old factoring rules for that. We're just basically backwards foiling right here. It's going to be x times x, and of course it's going to be 1 times 8. And since we have positive 7 in the middle, we need the bigger number to be positive, and that one's negative. I told you we're going to need everything we learned the last couple weeks is all coming together now. So let's recap that. We used synthetic division because they told us this is a factor. So since we know this one is a factor, x minus 4, let's go ahead and divide 4 into it, or in other words, I am dividing x minus 4 into this polynomial. I'm just doing it the shortcut way. And by doing that, it breaks down the problem into a smaller degree. Instead of having a third power, which I don't know how to factor that, I now have a squared power, which is easy factoring. And so what was the question? Find the remaining factors. Find the remaining factors. They are right there. Or all in all, this problem is this. If you were to multiply all this stuff out, it was x minus 4, x minus 1, x plus 8. If you went through all the trouble to multiply all that out, this stuff, like foil this, then whatever that is, multiply, distribute this into that, you'll end up with this thing right here. All right, this next one looks exactly the same as the last one, except this is just a higher degree. We have a 5th power polynomial right here. We have one factor of it. This one's saying if this is a factor, so they're saying this is a factor, find all the remaining factors. So let's do synthetic division again. So I'm going to put a -1 out there for the x plus 1. And this time, a little longer here, it's going to be 1, 1, 5, 5, -6, -6. And my first promise to you, like the last one, is this is going to be a 0 right here. The remainder is going to be 0 because this is a factor. And remember, -1 is representing x plus 1 as the factor. Shortcut to dividing right here. Bring down the 1. Multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. The most important thing there, once again, is that yes, that was a 0. And this right here is our leftover part. This is the remainder. This is the constant. This is x. This is x squared. This is x cubed. This is x to the 4th right here. So let's rewrite it. Let's write it x to the 4th Now notice there is no x cubed, it's 0. So the 5, the next one, is an x squared term. Then there is no x, because it's also 0. I'm looking here and here. This was 0x cubed, this is 0x. But we do have just a regular minus 6. So we're going to write that down. And then the remainder was 0. All right, something new coming up right now. Okay. Actually, we did do this a couple times, but it's probably still going to feel new to most of you. We need to look at this, and we need to see this as almost the same thing as if I wrote this over here. So if I were to factor this one on the right, it would be x plus 6, x minus 1. You can check that if you'd like. That's x squared right there. Then we have negative 1x plus 6x, which is 5x. And then we have 6 times negative 1 equals negative 6. So this thing right here factors to that. Notice this has all the same numbers in it. I put the 1 here, we got the 5 here, same as over there, and the negative 6 here. The only difference is, instead of x squared and x, we have x to the 4th and x squared. And the easiest way to explain this is just to do it real quick, and you'll understand. This is going to be x squared plus 6, x squared minus 1. First off, notice that this almost looks like the one I did over here. The only difference is that this is x squared and x squared. So check it. Ready? X squared times x squared equals x to the 4th. This is negative 1x squared plus 6x squared, which is 5x squared. And then still 6 times negative 1 equals negative 6. We can probably generalize this and just say a rule here. If this is a 4th power, and this is squared, and this is a number, constant, then try to factor it in this way. It's trying to be basically what this is, only it's doing it with these higher powers right here. But it has to be a 4th power, and a squared, and a constant. It's the only way it's going to work out like that. All right, well, we're not done. Okay. If you look at x squared minus 1, that factors also. That's x plus 1, x minus 1. X squared plus 6 does not factor. There's nothing you can do with that. Or in other words, that is a factor. That's a factor. That's a factor. The original x plus 1 was a factor up here. And that's it. It says if this, let's just start over. If x plus 1 is a factor of this thing, find the remaining factors. So they're telling me x plus 1 is a factor, so I took and divided it into the function, into the polynomial. So I put negative 1 here, did all this. The reason I did that, I knew this would be a 0 here. I knew this would be a 0. But I did that to break the problem down. Now it's only a 4th power right here. This part was a 4th power instead of it used to be a 5th power. I rewrote the 4th power, and I try to do whatever I can to that. They're going to be different. That's what makes these fun. Every problem's going to be a little different. So this one, you had to recognize that this looks a lot like this. It's a trinomial, 1, 2, 3 things, but instead of being squared x constant, it's 4th x squared constant. Well, that still works for factoring. And that last thing was that this is a special factoring situation where, see how x times x is x squared? These cancel out. You get negative x plus x is gone, and then minus 1. So this is just x squared minus 1. So that equals that. And that's it. Your answers are right here. Those are all the other factors that we could come up with. Next question, you can see it still looks like the same type of question. So the process is the same. It's just that the factoring at the end is going to be different for each one. So watch what happens in this one. Once again, we have the same wording. They're telling us this is a factor, of this, find the remaining factors. We have to find the rest of them. So the first thing you got to do is use that power they gave you. They're telling you that x minus 1 is a factor, so divide it in. So put the synthetic division, put the 1 on the outside, and then 1, negative 1. We're missing the squared term this time, so make sure you put a 0 there. This whole thing will fall apart if you don't see that. And then 8, negative 8. In other words, see how we have a fourth power, we have a third power, we don't have a squared power. But there it is right there. If we skip that, none of this is going to make any sense. So fourth, third, squared is 0, x, constant. Let's do the synthetic division. Once again, this is going to be a 0. I'm telling you, it's going to be a 0 because they already told us this is a factor. So 1, 1, add, multiply, add, multiply, add, multiply, add. There we go. So what we're left with here is the remainder is 0, as we knew it would be. Constant, just a regular old number 8. Then x, nothing there. X squared, nothing. X cubed. So this is x cubed plus 8. And now it's time to learn something new. Okay? You have to know that this thing right here factors, but it's very special. It's a very special situation. Whenever you have something cubed, and even if this is plus or minus, it doesn't matter. In this case, it's plus. If this is also something cubed, then there's a formula for this. So 8 is 2 times 2 times 2. So we could actually write this problem as x cubed plus 2 cubed. And there's a formula that says if you have something cubed plus something cubed, it equals. This is pure formula right now. I mean, we can definitely, investigate it a little further, but for today, we're just going to use this formula, okay? Whenever you have a problem written as something cubed plus something cubed, it equals, this is how you factor it, it equals a plus b, and then parentheses, a squared minus a times b plus b squared. So for this problem, where it was x cubed plus 2 cubed, that would equal x plus 2, because what's going on here is x is our a and 2 is our b. So all we're really doing is we're taking wherever we see an a in the formula over here, wherever we see the a, oh, not there, that's b. Wherever we see a, here, here, and here, we're going to put x. And wherever we see a b, we're going to put a 2. So we'll put a 2 here, 2 here, 2 here. So x plus 2, then we have x squared, and then minus, so ab, I'm actually going to write it different. It's a times b would be x times 2, but we should write 2x. So we're going to write it the other way around. So we're going to write minus 2x, and then plus 2 squared. Remember, b is 2, but 2 squared is 4, so we're just going to write it as 4. And that's it. So not only, let's recap on this one too, not only was x minus 1 a factor, because they gave us that as our little hint. Once we divided that into this, we shrunk it down to this cubed thing, the x cubed plus 8, which is right here. And now your new job today, most of this is review stuff, we're just kind of putting it together, but this might be new for you. You have to know this formula, that a cubed plus b cubed, right here, whenever you see it in that format like that, there can't be any stuff in between. It's just got to be something cubed plus something cubed, which is right here. Then you just plug it into this formula. Okay. It also works with a minus. I told you a little while ago it works with a minus. So let me summarize it on the next slide. So there you have it. This might look a little crazy at first, but really all it is, it's a way to write the formula once without having to separate the pluses and the minuses. So this is two formulas built into one. If something's written a cubed plus b cubed, then you use the formula that I just did. It's a plus b, so you're sticking to the top. See, this is the top thing here, so I was sticking to all the top signs now. It's a plus b, then parentheses a squared minus ab plus b squared. If what you had in front of you was a cubed minus b cubed, then it would be a minus b. Nothing, the stuff in, but this stuff doesn't change. It's just the signs. A minus b, then a squared plus ab, and it's always plus at the end, plus b squared. It always works out that way. So what's really happening, the way I memorize this, is that whatever the sign is here, that's the sign I use first. Then I switch it to the other sign, and then I'm always plus at the end. So whatever the sign is of the original problem you're trying to factor, that's the first sign here. Then it's the opposite sign, but then it's always plus. You can. I wrote sum and difference of cubes here too. You could Google this anytime you want. You can see tons more examples of it. It's, as I always say, it's not like it's a secret or anything. All right, so you have 5 examples. You got a new formula for factoring that will come in handy on some of these problems. That should get you started. You're welcome to start working on homework at home. Otherwise, though, you know we're going to have time in class. We'll work on it. I'll throw some new ideas up on the board. We'll have a good time. Until then, have a good night. Work hard. Be nice. See you soon.